Now, introduction of curve. Any drawing is a combination of straight line, horizontal line, vertical line, curve lines. Okay. Now, in these curves, so many curves are used for engineering branch and for construction of different objects. Engineering curves are very useful in engineering understand laws, in manufacturing of various items, in designing for various mechanisms, in analysis of forces, in construction of bridges, dams, water tank, etc. Now in this chapter, we won't cover so many curves which are classified in this manner. First, Conics curve, in which we will study circle, ellipse, parabola, hyperbola. Spiral curves, in which there are two methods, Archimedean spiral and logarithmic spiral. Cycloidal curves. So mainly cycloidal curves are classified in three: cycloid, epicycloid and hypercycloid. And in cycloid, there are another two curves which are position of the point on the curve of cycloid, inferior trochoid, superior trochoid. In epicycloid, inferior epitrochoid and superior epitrochoid. And in hypocycloid, inferior hypotrochoid and superior hypotrochoid. Then involute curves. So involute curves are drawn of different shapes of like circle, line, different polygons, triangle, square, pentagon, hexagon, etc. Now for particular conics, first of all we have to understand what is cone or the terminology of the cone. Cone is one solid object which has a circular base and there is one apex. Axis of the cone which is passing from the apex and center of the base. Then the lateral surfaces are nothing but the combinations of lines from apex to the periphery of the base. These lines are known as generators. Now angle theta, which is angle between the axis and the extreme generator, is known as angle made by generator with axis. And the double of theta means 2 theta is known as apparator angle. Now, definition of conics. How conics curves developed. So if a cone is cut by cutting plane at different positions with reference to its axis and base, then the curves of intersections are known as conics. And the different curves of intersections are triangle, circle, ellipse, parabola, and hyperbola. Triangles. Okay. This is my cone, and when the cutting plane contains the apex and cuts base of the cone, then the curve of intersection will be triangle. If we cut the cone with the use of cutting plane and the cutting plane is passing from the apex and axis, then the true shape of section is triangle. Now for circular arc, when we cut the cone with cutting plane and if the position of the cutting plane is such a way that it is parallel to base and perpendicular to axis, then the true shape of the section will be circle. When the cutting plane is inclined to the axis at an angle theta and it cuts all the generator of the cone, then the curve intersection will be ellipse. So here the cutting plane is inclined to axis and the angle of this cutting plane is less than theta angle. then the true shape of sections obtained is ellipse. When the cutting plane is inclined to axis at an angle equal to theta, or you can say the cutting plane is parallel to one of the generator of the cone, then the curve intersection will be parabola. So you can see here this cutting plane is parallel to this generator, or the angle of this cutting plane with axis is exactly theta, then the true shape of section obtained is parabola. For hyperbola, when the cutting plane is inclined to axis at an angle more than theta, then the curve intersection will be hyperbola. And if we take the cutting plane parallel to axis, then the curve of the intersection will be rectangular hyperbola. So here, if the cutting plane angle with axis is greater than theta, then the true shape of section is hyperbola. And when the cutting plane is perpendicular to base or parallel to axis and which is not passing from apex, then the true shape of section will be rectangular hyperbola. Now let us see the definition of ellipse. Ellipse is a curve traced out by a point moving in a plane such that the sum of its distance from the fixed points will remain constant and is equal to major axis of the ellipse. Now what is the application of ellipse? So the ellipse curve is used in the shape of tank like this. You can see the milk tank or water tank. The shape of the periphery of the tank is exactly ellipse. Then the shape of breeze and arches, designing elliptical gear, path of earth moving around the sun is also elliptical shape, and shape of trees is also made of ellipse shape. Now parabola. So parabola, it is the locus of point which moves in a plane so that its distance is from a fixed point focus and fixed straight line directrix is constant and is equal to 1. This ratio is known as eccentricity. So what is the application of parabola? It is used of the shape of motor car headlamp reflector. You can see this shape is of parabola. Sound reflector and detector also available in the parabolic form. Again, construction of breezes and arches. It is also of the shape of parabola. And path of any particle thrown in air at an angle, projectile motion of the particle thrown in air. So when you throw any ball or any object in the air, the profile of that particular object is exactly parabola. Now, hyperbola. So, hyperbola is a curve traced out by a point moving in a plane such that the difference of its distance from the fixed point will remain constant. So, here you can see the application of hyperbola is in cooling towers. Cooling tower is used to condense the steam in thermal power plant. So for that purpose, the construction of the hyperbola is designed in such a way that there is a creation of draft to uh, create the pressure difference. So here the shape of the cooling tower is hyperbola. Now rectangular hyperbola, the shape of graph pressure versus volume for isothermal process, or in the Boyle's law, the curve of pressure versus volume is exactly hyperbola. So here when pressure is decreased, volume will be increases. This path follow rectangular hyperbola curve. Now at the last, here in this chapter we will discuss different methods of the ellipse, parabola and hyperbola, and what are the applications of ellipse, parabola, hyperbola is mentioned here. For ellipse, we will study the oblong or rectangle method, ellipse and parallelogram, concentric circle method, arc of circle method, directrix and focus method. And for parabola, there are four methods: rectangle method, parabola in parallelogram, tangent method, directrix and focus method. And for hyperbola, rectangular hyperbola method, oblique hyperbola, foci and vertices method, and directrix and focus method. Okay, thank you very much for watching this video.